So next up, we have the talk on a hierarchical attention networks based model for. Good morning, everyone. So today, basically, I am presenting work which was done by one of my students, Anurag Yadav. So we just started this particular domain. This is the very first work we did. It's a sort of preliminary study which we had done so to basically understand what could be achieved and how we can take up this problem further. Right. So he couldn't make the student, so I am presenting in his behalf. The title says that like it's a the problem which is addressed is a bug report prioritization, and we applied the hierarchical attention network, which is one of the NLP model which can solve the problem. So basically, so the outline would be, so I will be introducing the problem first, then obviously some of the background information and all, what is the approach we proposed and what we have found and what we can, what things we can take from this so that we can plan the future studies. The idea is very simple. We have the bug is something which is always there in the software development, and somehow we have a proper cycle where we first, when there is a bug, we assign it to someone, then somebody fix it, and then we take it to the production and also that was the general process. The problem is that the sheer volume is now very high. The bug reports are we are getting the hundreds of bug reports daily, and we cannot treat everything at a same scale. So somehow we're supposed to come up with the priorities, like this is the thing which do first, this you do second. So maybe yeah, somebody must be doing it. So the thing is that there is a person who has some experience think, okay, this is something we're supposed to look first, this something which can be delayed, and also the person is basically doing that assignment, and we think, okay, can this thing be automated? That's the very thing, and it is automated. People were doing it. It's not like we are first looking into the automated perspective. People are doing it. We see, okay, what they're doing and what could we add in that thing. So we think, okay, this particular, which is the HEN network, can it be applied here? And if it is, it can solve the problem, right? So typical bug report is something like this. It's some tags which are basically describing the summary of it, which product it is, who reported it, what is the severity, the priority, and all, and then a lot of text actually. Since there are lots of text also, so it could be a problem which can be solved by the NLP models also, right? So that's the basic underline we had. So the typical solution is that there is a trigger who is doing it. So taking the report, looking for this validity, for the duplicacy, do the priority assignment. This was the we were talking about, and then it must be assigned to some person. That person must be solving that bug and all, right? So and typically it's not. I am not saying it's always 5 on a scale of 5, but typically it's P1, P2, P3, P4, and 5, where P1 is the something which is the topmost, and P5 is the trivial one, and somewhere the other are the intermediate only, right? So this is the common priority assigned to the bug reports. So we applied a typical pipeline of machine learning, right? It says that we take the data, obviously it's having the reports, lots of reports, the raw reports, which supposed to be processed so that we can have a refined one which can be taken up by the models. So we refine them, then we apply typical tokenization and embedding approach. We can have something which can be fed to the model. It's something numerical vectors which can be generated. Once we have this, a typical partition of training testing, we found that data is heavily tilted towards the P3 priority, which is a typical medium priority. So we found that has a highest representation, others are having relatively low representation, which can make our model biased. So we balance that data also, and then we build our model. Then we evaluated our model on the testing data, evaluated how good it is, right? Typical machine learning, the pre-processing to get rid of all the unnecessary information from the data, which could be either lowering the cases, punctuation remover, stop word remover, stemming, and all. Right. So typical pre-processing we have done here. For the tokenization and embedding generation, we applied a lighter version of BERT model, which is a digital BERT. It's it's almost as good as the BERT model, but it has a 40%, it is 40% fast. So we think it could be, this light model can be something which can help us. So we used it, and it was proposed by the Hugging Face library. They proposed it. So we tokenize our, obviously the text, and then the embedding will be the globe, which look into the co-occurrence of the sentences and all at a broad perspective, so that we can have a vector which can capture more detail compared to the individual detail of the individual birds and all. Once we done this, then obviously we looked into this, we feed into this HAN model. The idea is that this has a common hierarchy. Its model is hierarchical, and since our problem is like we have the sentences, the birds which are building the sentences building the paragraphs, and which is basically the whole document. So why not this? So this is a automatically favoring thing which can be applied. So that's why we opted for this, and then we obviously did a lot of fine tuning of this model and all to solve our problem. So we tried with the parameters, and we basically testing and lot of training and optimizing of it. And we came up with one particular architecture of which having us stacked of the layers of embeddings and the RNN model and bidirectional. And also once the model is trained, so we say that okay, where to test it. So we got the data which was proposed by the Sanfang in one of the papers. We also compared the result with this same paper also. So we applied for the Mozilla data, the Eclipse one, the NetBeans one, and GCC one. Right, there are 4 different projects which we got, and then some obvious thing which we do with any machine learning model, like common optimization. So obviously, ADASIN for resampling, we did the evaluation for the different batches for the epochs till it is converged and not didn't show any further improvement. And then we use some optimizer which is Adam and all, and a cross entropy for the loss as a loss function to basically train the model, right? So this was something when we think okay, this is now saturating and there is no need to further train it, right? So it's saturated somewhere around 9 or 10 epoch and all. This was the results, preliminary results for in terms of precision, recall, and F1 score. This is ours, and we compared with the obviously the baseline CNN model, the SVN and random forest. Also for SVNs, the random forest and SVM, the obvious thing is we use the TF-IDF sort of thing to basically capture the features, which is a traditional way of doing the feature extraction from text. For CNN, obviously the same tokenizer is there, and this one is the one which I have taken data and I also compared with it. So we found that our result is not something which is a drastic improvement and all. We are somewhere getting those results. So we say that it's a minor improvement. In some cases it's not even an improvement. So we see that okay, this thing can get the performance, the state of the art, but it cannot basically beat the it cannot be something which can replace the existing technology. Must so be supposed to look into it, like what can be done and how it can be improved and all, so that it can be applied to the journal projects, right? So these are the things, these are the findings we have. We found that one of the key problem is that the data is, even we try to balance it, it is not representing the P1, P2 priority, which are the critical ones. P3, P4, P5 are something which are not that critical, they are trivial ones. So one obvious thing is to collect more data about it, to basically get to know what these things are, so that the model can learn from them. And also one of the challenge we will be looking, obviously we will be collecting the data and we will be fine tuning the model and all. We also look where it failed actually, what was the thing, so that it can overcome those problems also. So this is more or less the same conclusion also we got. And so I conclude at this point. And this one small mention, this was the project which was supported by funding from the ministry. So the mention for the same is here. Right?
Yeah, let's thank so any questions or comments?
Across different software domains, did you also look at bugs for embedded software, safety critical embedded software, maybe for aerospace applications or automotive applications? And how does this compare to, let's say, classical standard enterprise resource planning software?
Yes, I think you are asking like we have the different domain of the projects, how it can be applied there. Yeah. Yeah, this is the thing. Currently, we had the reports which are available in the Bugzilla actually. So they may have one way of representing the bug reports actually. So if that is we have a shift in that in the embedded or some system, then obviously this thing need to be tuned there actually. It cannot be applied. So that is one thing which we haven't looked up, but it's something we will be obviously doing because we cannot rely on one way of representation only. What we may be looking at is certain fields which must be there. A bug there, then what they are representing in that report, that can then it can help basically a better prioritization. So we obviously look for into it in the future. I hope I answered it.
Yeah, one question. So, since you mentioned that you are using hierarchical network, right? And it seems that the bug reports have some structured and unstructured data. So, how do you identify the structured part of it, and how do you get the hierarchy out of it? Like, is it a manual process or automated process? And how do you identify the parts, like the structured part through which you may map it with the hierarchy, as well as the unstructured part, as you mentioned you have priorities for the bugs, then you need to identify bugs.
There are two things. First thing is for sure we haven't done it. We haven't anything manually, so it's not we are getting the hierarchy manually and all. It's automated. The thing is that when we have a report, the raw report, we must be pre-processing it and remove that, getting rid of all the thing which is not required. The key thing which is required to make the decision only is there, and once it is there, we want it as a single textual description of that thing. And then from there we basically generating the embeddings and then feeding to the model. So it's more or less like it handling. It's not a multi-model sort of thing, like handling one is handling the unstructured one is handling the structured one, then clubbing them together to process further. It's not like this. We did it at a pre-processing step only, removing all the things which are not required to make a decision, and the things which are required to make a decision, we merge it and then treat it as a single input.
So how do you like identify which things are not required, like the part of pre-processing you are mentioning? So
Obviously the thing is that I think we had a report description here also. So let me just go quickly. So I think when we have the description here, so obviously we will be looking about the summary more, the components, other things like the reporters, the comments sometimes can help, but we mainly looking for like what is the summary of this particular bug and what is the comment letter sometimes, and these things like assignee and all we are getting rid of them actually.
so as he had also mentioned, like if the way in which these things are specified in the bug report differ, then how do you configure the framework?
That's why I also say it's something we haven't looked till now. It's something which we just started. So it's something it's the first thing. What are the challenges just to explore it? So if there is a shift in this thing, obviously we need to look. Means what are the critical things must be there to make a decision. If not there, then we obviously cannot take up in our input as an input actually. That's one of the challenges.
Yeah, because the pre-processing you mentioned, I think it is more of automated pre-processing, and if at all the manual pre-processing that you mentioned, that we are only looking for these key things only and we are ignoring the rest of the things. So that part, if at all is manual, then it may take some efforts based on the volume of bug reports.
Yeah, thing is that I'm not I cannot even currently not say with the 100% confidence if something was truncated, because the thing it was done by the student, so he may have truncated, but I can say that we are not going with any manual thing. So let I'll look into it, but there is no manual thing.
Thanks for the discussion. I hope that we will continue in the break time also.
Right,
Just
right.
one quick comment, Santosh, I wanted to ask. You have the priority here for the bug, right?
Right,
So
yes.
when you say bug report, when you say that no bug report priority, I think that's something that I don't know. Maybe it would have been defined in the paper, but it will be interesting to see if there is a correlation saying like there's
Okay,
typically
you-
a priority for the bug.
Okay, I
What
got
was it,
it. So
right?
you are saying you are saying the already bug is already prioritized. So how it is different from the report priority?
No, it would be different,
Huh.
but I am saying like it would have been. It may be there in the paper. It could be
Right. So I think like since it's we take the database supervised, so every report is labeled with one priority, which
Yeah.
is I think it's resembling this bug report only, because a report is something which is about the bug actually. So I can say I
probably
think
we can discuss offline. Then
yeah,
see if I am
great.
interested. Okay, so let's thank the speaker again.